Hello, Light and Geometry students. Today we're going to talk about translations. A translation is a transformation where we simply slide our object left or right, up or down. So in this case, if I want to perform a translation on this triangle, I'm simply going to slide it to the right a little bit and then slide it down a little bit, and I'm going to create a new triangle in a different location. The triangle is not grown or shrunk, so no dilation. It has not been rotated, it's not spun around, and it's not been reflected, it's not backwards or upside down. This is a translation. Again, a translation is simply when we move the object left and right, up and down. Examples of translations are simply cutting and pasting an object. Here we have the same object, no changes to the object, it's just been moved. In geometry, our translations will look something like this. We're going to take a shape, starting with a triangle, and simply move it either to the left or the right, up or down, or some combination of those. So, to give you an idea what our translation is going to look like, we're going to use Geogebra, and you don't have to make this one. I'm just going to show you roughly how this works. We're going to select our object, and then talk about how we want to move that object, and create a vector that moves the object. Here I'm going to move my count 4 spaces to the right and 2 units down. Oh, that didn't work. There it goes. And so our cow is going to move. It's just going to slide to the right and down in this case. For you to do this, we won't have to do it with the cow. We're going to create a picture with a triangle in the Geogebra app like we did with reflections. And eventually, you won't have to use a graph or a picture at all. Translations can be very easy even without the picture. But at first, we'll start with the pictures. So you're going to go to geogebra.org. When you get to this page, you're going to select under their apps, you're going to select the Geometry app. And just like with reflections, we're going to get a blank background, and we're going to want a graph in our background. So we're going to right-click, that's Alt-click or the 2-finger click, and select Show Axes. And we're going to do it again, right-click, and show the grid, select the major grid lines, so we have this picture. We basically have a graph. Next, we need an object to perform our translations on. We'll do the same one from yesterday. We're going to create a triangle. So over on the left side, under Tools, you're going to select Polygon. That just means shape. And we're going to draw a triangle. First, click at -1, 1 to create point A. Then -4, 1 for point B. Then -4, 3 for point C. And then you got to click back on point A to complete your triangle. So here is our triangle, and we're going to perform a translation on it. We're going to try to move our triangle 4 units to the right and up 3 units. To do that in GeoGebra, we're going to want a point here at the origin. So you're going to go over to the left under Tools and select Point, and we're going to click and put a point at 0, 0. It should pop up as point D. Then go under More Tools, scroll all the way down, and find the transformation functions. We're going to use the Translate by Vector. So you select Translate by Vector, and we're going to click on our triangle, and the triangle should highlight when you do that. And then to show how we want to move it, we're going to click on that point D we just created, and it should highlight, and we said we want to go right 4 and up 3. So it's like graphing a point. I'm going to count right 4, 1, 2, 3, 4. As you're doing this, a little arrow should be showing up. And up 3, 1, 2, 3. Notice I haven't clicked yet. I'm going to click here. And it took our triangle and it moved it right 4 spaces and up 3 spaces. Now, the original coordinates for point B were at -4, 1. What are the coordinates for B prime? B prime is at 0, 4. And here all the other coordinates have been moved as well. Now there's a very simple pattern to what happened to these coordinates. Point A went from -1, 1 to +3, +4. Point C went to -4, 3 and moved up to 0, 6. Now how these coordinates changed is actually really simple once you see it. So what we want to do is talk about a shortcut and take the graph right out of the problem. Here was our original triangle, point A at -1, 1, point B at -4, 1, and point C at -4, 3. The original triangle, again, is called our pre-image. That's our starting picture. Our new one, which is called the image, A prime is now at 3, 4, B prime is now at 0, 4, and C prime is at 0, 6. The pattern to how these numbers change is actually very, very simple. See, we moved right 4. Left and right is the x coordinate. That's how did those x coordinates change? Well, here are the x coordinates for all the points. Negative 1 became 3, negative 4 became 0, negative 4 became 0. To move right 4, we simply added 4 to the x coordinates. To move up 3, well, up and down is the y coordinate, the second number. If we look here, we have the same pattern. If we move up 3, we simply add 3 to each of the y coordinates. So we added 3 to the y coordinates to move it up 3. So here was our problem. Say we had, or a different problem. Say we have moved this point, 5, 2, right 10 and up 6. Okay, right 10 means we're going to add 10 to the x coordinate. 5 plus 10 will give us 15. Up 6 means we're going to add 6 to the y coordinate. 2 plus 6 will give us 8. So we can get this problem. We can figure out the coordinates of our translated point without even graphing it. Now, for geometry, we have a little bit of vocabulary to fix here. Instead of saying right 10 and up 6, we're going to show it with symbols. So we don't have to write out those words. The first number tells you left and right. The second number tells you up and down. It looks like it's a coordinate, 10, 6, but we have these funny parentheses. When we use these funny parentheses, this is telling you how to move the point. Right 10, up 6. Almost the same as the point, except we're not starting at 0, 0. We're starting at 5, 2. And instead of move the point, we're going to say translate it. So we translate the point 5, 2. We're using this, which is called the vector, using the vector 10, 6. And that just means 5 plus 10 is 15, 2 plus 6 is 8. There's our new point. So here's a problem we can solve without graphing it. Translate the point A at 4, -1 with the vector 6, 5. All right, so the vector 6, 5, the first number is left and right. That means we're going to move right 6. And the second number is 5. That's the up and down. So then we'll move up 5. So to find the new coordinates, we're simply going to add 6 to our x coordinate and add 5 to the y coordinate. 4 plus 6 is 10. -1 plus 5 is 4. So the new point, A prime, is at 10, -4. Now, we've been only moving right and up, but to move left or down is not much more difficult. Here, if I wanted to move this point with vector -3, -1, well, -3 means we're going to move left 3. -1 for the y means we're going to move down 1. So instead of adding, it's subtracting, or you get to think of it as adding -3. 4 plus -3 is 1. -1 plus -1 is -2, so we get our new coordinate. So here's a problem to try. Move the point A at 7, -6 with the vector -3, 8. Find the new coordinates for A prime. Well, -3 for the first number, that means we're going to move left 3. Positive 8 means we're going to move up 8. But all we really have to do to find the new coordinates is add these two numbers in the vector to the two numbers in the point. 7 plus -3 is 4. -6 plus 8 is going. So we get the point 4, 2 for A prime.